and welcome to this section. In this lesson, we will learn how to solve linear equations, work with equations involving fractions, identify different type of equations, and solve real-world application using mathematical models. A linear equation is one variable can be written in the form of ax plus b equals 0. This is a linear equation in one variable. We call it linear equation because variable has an exponent of 1 and here the variable is x. Then we have a and b. A and b are real number. A and b, they belongs to real number from negative infinity to positive infinity. And the only variable here is x with exponent 1, so we call it linear. In other words, there are no squared, no cubes, or higher powers of the variable. So the equation, for example, 3x plus 5 equals 17 is linear because x has exponent 1. However, if I have 3x squared plus 5 equals 17 is not linear because the variable is squared. Now the question is, when we have a linear equation, how we can solve it? When solving equations, any kind of equations, our goal is to create equivalent equations. Equivalent equations have exactly the same solution. And there are 4 common operations to have the equivalent equations. Suppose we have x plus 7 equals 12. If I subtract 7 from both sides, then I have x equals 5. Since here we perform the same operation on both sides, the new equation is equivalent to the original equation. I mentioned that there are 4 common operations to have equivalent equations. So let's suppose that I have a equals b, and this is one expression. One way to have equivalent equations is to just simplify the expression. If it's possible, there are some terms in the left and right, and I can simplify, then we just simplify the expression. Another way is by adding or subtracting the same quantity from both sides of the expression. For example, here I have a equals b. I am allowed to add or subtract the same quantity to both sides. And a plus c is equals to b plus c. And also I can write it as a minus c equals b minus c, and c here is a real number, so it can be positive, negative, 0, and any kind of real number. Another way is to multiply or divide both sides by the same non-zero quantity. So when I have a equals b, I am allowed to multiply both sides by c or divide by both sides by c if c here is non-zero. Why c should be non-zero? because we are not allowed to put 0 in the denominator. If we put 0 in the denominator, then the fraction is undefined. So these are the four common operations that give us the equivalent equations, and we use these to solve a linear equation or any type of equations. Let's solve our first linear equation. We start with this 3x plus 4 it's equals to 19. Okay, the variable term, which is 3x, is not isolated because here we have a positive 4 in the left hand side. So let's start by subtracting 4 from both sides. If I subtract 4 from both sides, then I have 3x equals 19 minus 4, it's 15. So the new equation that is equivalent to the previous one, it's 3x equals 15, and this is equivalent to 3x plus 4 equals 19. Now we divide both sides by the coefficient of variable x, which is 3. Okay, if I divide it by 3, then we have x equals 5. Always check your answer. How we can check the answer? We plug 5 in the original equation, and then we have 3 times 5 plus 4, and we check if the answer is equals to 19 or not. 3 times 5 is 15, then we add 4, and yes, it's equals to 19. Let's solve new example. 3x plus 4 it's equals to x plus 19. So to start, we can subtract x from both sides because you see variable x in the right and the left, and we want to isolate the variable in one side. So I'm going to subtract x from both sides. So if I subtract x from both sides, then we have 2x plus 4 it's equals to 19. Then we can subtract 4 and we have 2x equals to 15. And for the last step, we can divide by coefficient of x, which is 2. If I divide it by 2, then we have x equals to 15 half, or 7.5. And also we can check if our answer is correct or not. We use the original equation and we plug 15 half or 7.5 and to check if our answer is correct or not. So we have 3 times 15 half plus 4, and we check if it's equals to 15 half plus 19. We do the calculation to see if our answer is correct or not. The next concept is linear equations with fractions. Students often find fractions intimidating, but the strategy is straightforward. The key idea here is to eliminate fractions first. So we do this by finding the least common denominator, or LCD. For example, consider x third plus 1/2 equals 2. There are two denominators here, 3 and 2, and LCD, or least common denominator, it's multiplication of 2 and 3, because 2 and 3 both are prime number, so it's 2 times 3 or 6. So we simply multiply both sides by 6 to get rid of denominator, to eliminate denominator, and then we follow the previous rules. So if I start by multiplying both sides by 6, x third times 6 becomes 2x, and then 1/2 times 6 becomes 3, 2 times 6 is 12. Now I have one equation without fraction, and then to solve the equation we simply can subtract 3 from both sides. Then we have 2x equals to 9, and for the next step we can divide both sides by the coefficient of x, which is 2, and x it's equals to 9/2, or 4.5. Again, you can check if 4.5 is the correct answer by plugging 4.5 here instead of x, and check if it's equals to 2 or not. The next concept is types of the equations. Not every equation behaves the same way. There are three important categories here. One category is the conditional equation. Conditional equations are a type of the equation that they are true just for a specific value of x. For example, if I have x plus 2 equals 5, this statement is true if x is equals to 3. So we call it conditional. If x is 3, then I can conclude x plus 2 is 5. So it is conditional. The next type is identity. These type of equations are true for every real number. For example, 2 times x plus 1, it's equals to 2x plus 2. No matter what value of x you choose, both sides remain equal. Another type is inconsistent equation. They never true. For example, if I have x plus 5 equals to x plus 2, this is inconsistent equation, because if you subtract x from both sides to solve the equation, because you want to isolate x, right? Then you have 5 equals 2, and we know that this is not possible at all. So we call it inconsistent because it is impossible. Okay, let's summarize today's lesson. We learned how to solve linear equations, check solutions, eliminate fractions by using the least common denominator, identify conditional equations, identities, and inconsistent equations. I encourage you to work through several practice problems on your own. The more equations you solve, the more natural the process becomes. Thank you for watching, and I will see you in the next lesson.